Hi guys, my name is Mando, and this is the long version of the phone detection at school. Obviously, we're doing phone detection to prevent students from scrolling on TikTok and instead improve education by having the student listen to the teacher, learn by the teacher, learn from the teacher, and then do more writing and do more actual classwork, right? So as the program is loading, I'm just going to show you guys the code real quick. So I'm Agent IDE builder, but you guys don't have to be using that. So I guess as I'm explaining the code and the program of it, we can actually see it live, right? So let me just do a quick demo real quick. So let's say I'm a student, right? And then I'm like looking at my phone and I'm just like scrolling and not paying attention to the teacher. And I'm just like blah, blah, blah. I can even change angles and be like over here. And I'm just like looking at this. I'm not paying attention to the math teacher. I'm just like whatever, just scrolling. As we can see, we logged 2 different times, okay? So the first one is the time that started and the time that ended. So the student, was using the phone for about 7 seconds. And the confidence, I'll explain later, but the closer this is to 1.0, meaning like the more precise the AI is, or the application, in determining that the student was actually using the phone. And then there was a second time the student used it for 8 seconds, and it's at a 0.85 confidence level. I'm going to explain that now, but actually there was a lot of trial and error. This took me about a week to build. It's not a full production application, but it is very close to that. And if anything, it's at about 95% production ready level. And the reason for that is for some limitations and other things. So for example, the camera is facing this way, right? Meaning that the program or the model that we're using is called YOLO, which was developed by some developers. So we're using their technology and their Python scripts. So at this angle, the program records it very well because the phone becomes more flat. But as you saw, even when I held the phone in this manner, it still recorded very well the phone usage. So we have a little bit of limitation in terms of like using someone else's model. So I'm using this model called YOLO. You can probably find it on GitHub. I'm going to post all this code on GitHub anyway. Let me see where the program is. Okay, there it is. So we're using the YOLO model. And also the other limitations of this program is I have a 2017 MacBook Pro camera, RGB camera. There's so many limitations to this camera, but we were still able to record very, very decent phone detection, right? So the camera position would even be better if it was at this angle. Okay, at this angle and possibly at the corner of the classroom, we will get better detection. Okay, and then also if we include infrared, if we include depth means like being able to distinguish the 3D objects from the person. Infrared, because sometimes the students turn off the lights and they like to use the phone at night or with the lights off. All that stuff, we were being limited because of the hardware of my computer and the limitations of the YOLO program. But like I said, still did a pretty decent job, and the file was sent to the principal, or it can just go straight to the principal or the teacher's desktop. But we can also do an API through Google and Google Sheets and have it sent directly to people's email. That's not a problem. And so let me just quickly run through the code. You guys already saw how the program works, and there's a lot of stuff that you didn't notice. A lot of failure I had, a lot of thresholds that I had to play with. There's some variables here that we have to understand how the confidence formula is basically made up and what it contributes to the importance of the detection. So for example, If the camera detects the phone on the table, that's not good enough to say that the student is cheating or looking at their phone. The phone, this is at a 60% confidence, right? But that's not good enough. It has to be in combination with hand positioning. So when the hand is positioned around the desk area or around the lap area, plus holding the phone, this is what creates the trigger event that tells the program to record it on the CSV file. Also, there's another element of glow. So if the phone glows at a certain lighting and my head is tilted, this is by what I mean by detection of head tilt, not face recognition. That's something else that includes privacy and stuff. But those 3 factors or 4 factors, right? Phone in hand, phone up, detecting the phone, plus detecting that the phone is with the hands around this area. So when I put my hand up like this, it's going to detect my hands, but it's not in the area below the waist or around this area. That's going to be triggering the phone usage, right? So also, it's not going to trigger the phone detection cheating phase if my head is tilted alone, because if my head is tilted, I could be reading, I could be whatever, writing, right? Or if my hands are moving, the trigger is not going to start the program detection or the recording of the phone detection, because it needs a combination of these 3 or 4 elements in order for the confidence level to be above whatever 0.7 or higher, or 0.5 or higher, whatever the threshold is, in order for us to be confident that the student is doing phone usage. So that was a long explanation, but the code will basically say the same thing I just said. So if we look at the code here, the CSV is just where the stuff was printed. We're using Mongolia time. I'm doing a project for a Mongolian school. And this is what I was talking about. So the most important one is responding to the phone, which is at a 60% on detection, and 25% together with, like I said, the phone being, the hands being around this area. And finally, we have the head tilting. So if the head is tilted, it boosts our confidence that the student is using the phone. So a combination of these 3: phone detection, hand detection around the area, and head tilted is what makes up our confidence level. And so then we have our threshold, like I said earlier, what triggers the event of the phone detection. And this is basically 2 seconds. If the student is holding the phone for minimum 2 seconds, 1, 2, boom. And all the variables are connected, hand area, phone detection, head tilted, then it's going to trigger off the event, meaning that it's going to start recording that the student is actually using the phone. And then obviously this is our AI model. I didn't create my model from scratch. That would have taken months, but this model is good enough. But if this app ever goes into production, then we can probably use our own model or either improve it, because this model has some limitations, meaning like the angles of the phone, lighting, all kinds of stuff, depending on how the model was trained. Okay. And all this is just the CSV stuff. This is the CSV columns. This is just the event start and finish time. This is our definition, obviously, with the Python code. And we have our while true statement here. And then this is related to the angles and the X and Y's of the YOLO model, the way we can talk to it. And then this has to do with the hand detection, right? All this stuff you guys didn't see, but all this stuff is happening in the background, okay? This has to do with hand detection. The hand zone, I told you, it has to do with below the waist or around this area. So, like, if the phone is up here with my hands, it's not considered phone usage because the student is maybe taking a picture or something. The phone location or hand zone has to be within this area, desk, above the desk, around the waist, not above the head or anything else. And like I said earlier, the head tilt is when um, the camera detects that my head is being tilted, meaning it boosts our confidence that the student is using the phone, right? And then, right, this is just more code about the event logic and how to log stuff to the CSV. The UI is just basically those bars that you saw earlier about the confidence level. You don't have to worry about that too much, but basically, the higher the confidence level, the higher it is, or closer it is to 1.0, means that we're super confident that the student was using the phone. If you get a confidence level of 0.78, that's still pretty good. Even 0.5 is kind of our threshold, but I'm just letting you know, if you get a confidence level like we got at our CSV file, which was at 0.85, that's actually very, very good, right? And that's pretty much the end of the code. But again, my name is Mando, and we just did a phone detection for school to help teachers and students and the principal identify which student. Now, if you want to move this app into production code, meaning you want to do like 200 students within the camera, then we have to not improve the code, but add to the logic of student zone desk, student zone 2 desk, student zone 3 desk. So we separate the students into desk zones. And then for privacy issues, then we can do face recognition. We can also do face detection. We don't have to do face recognition, but we can start labeling this student that sits in this corner for the whole semester or for the day was using his phone for about 40 minutes during class, which is pretty bad, right? Or this student over here is using the phone for 20 seconds. Maybe he's just checking his mom's messages or parents' messages, checking email real quick. So we can detect which student was actually using the phone longer, and therefore we can call the student to the office or have a talk with the teacher, have a talk with the student, whatever, in order to eliminate this sort of like distraction of TikTok scrolling or whatever, in order to improve education and learning in the classroom. Again, guys, my name is Mando, and I'll see you guys on the next one.